So here we're given some starting information that the integral, the definite integral from 0 to 1 of x cubed is 1/4. So I have that labeled here on our graph in red. So this function right here, red is our our function of x cubed. So what they tell us, I'm going to go ahead and put in some areas here. Just from 0 to this border right here of 1, they tell us that this area right here is 1/4. Now what we're tasked to do is we're supposed to evaluate this other integral. We're supposed to use this to help us get the value of this integral I've highlighted in blue here. Now what they want us to see, what we're hoping to do, is that we see the relationship. So on the graph here, I have graphed g of x as the cubed root of x. So we can see that right there. There's our g of x. What they're hoping that we see is that g of x is the inverse of f of x, right? Why do we care about that? Which means it's reflected over the line y equals x, which you'll notice I also have in green. So why do we care about the reflection? Well, it creates some symmetry. So this right here is obviously the point 1, 1, and we're only looking between 0 and 1. So if I just look in this black window has an area of 1, right? It's 1 by 1. Now what we see is that since this red graph here and this blue graph are inverses, it means they're the same distance away from that line of symmetry, which is y equals x. So if we kind of visualize that, like for instance, the distance from here to here, they're all going to be the same, right? So this distance is the same as this distance. This distance here will be the same as this distance here. So all these things are the same, right? So if it's the same distance from here to here, then it's obviously the same distance from here to here, right? Because we have a square. So what they're trying to get us to see is by symmetry, this little portion right here is also going to be 1/4 because of the symmetry of these two functions. So if we're looking for the area under the cubed root of x, which I'm now shading all in blue, so what is the area under this curve? Well, the entire area of the square is 1, which I'm doing in black. So 1 is the entire area of the square. And then we take away just this little corner up here. This is the only area that's not under our blue curve. So we take away that area of 1/4, which leaves us the area of the blue section as 3/4.